Hello, in this video we're going to be talking about the phospholipids. Let's not waste any of your time. Let's get right to it. Now, when we're talking about phospholipids, the one thing that we have to keep in mind is that polar nature. Okay, that phosphate head, it's charged. It's got that polar oxygen, and those fatty acid tails that are nonpolar, they're not charged. Okay, that brings about that association with water by the phospholipids. That's why they orientate themselves to water. The fatty acid tails that do not interact with water. So when water comes through, it's pulled through by the phosphates, and it's not slowed down by the tails. So it just moves right on through. But that's just a super important topic to remind yourself, that hydrophobic, hydrophilic aspects. And of course, we've talked about the phospholipids a couple of times already. We mentioned them in the macromolecules, we mentioned them in the organelles, and now we're going to mention them here again. So super important object. So just remember the structure of it. It's got that glycerol backbone, which is that kind of that middle section right above the tails. If you remember in the macromolecules, the lipids. It's got that glycerol backbone, and in the triglyceride there are 3 tails, so this is just 2 tails. So diglyceride perhaps. Okay, and then that phosphate head at the very top. If you're looking at that picture below me, the phosphate head is in that kind of a yellowish tannish circle at the top. The glycerol is in the middle, in kind of the orange of the salmon, and then of course the fatty acid tails down below there. Of course, we know the tails are nonpolar, non-charged, hydrophobic. The head, charged, polar, hydrophilic. And of course, as I mentioned, in an aqueous solution or a water solution or a solution of some type, the phospholipids will orientate themselves directly with the fatty acid tails on the inside, and then the phosphate groups facing the surfaces. Okay, so when we're talking membrane structure, okay, we want to talk about some things here that bring about kind of the properties or the various functions. So when we're talking, I mentioned this in the first video. But having those double bonds in those fatty acid tails, those kinks, creates a big difference in the bilayer. You can see there's a picture over on the far right. If it was just saturated fat tails, you can see how dense that is. Viscosity would be low. The tails would keep everything nice and tight, and things would struggle to get through. But when you, the bottom by half of that picture, but when you add the unsaturated tails with those kinks, those double bonds in them, you can see that makes it a little more flexible, a little more fluidity, a little more room to move through. Okay. And of course, along with everything else, the conditions the membrane finds itself in, especially when in regard to temperature. If it's warmer, okay, the membrane is going to be more fluid, more flexible. If it's colder, it's going to be less fluid, less flexible in that manner. Okay, this we've mentioned a couple of times. The picture 2 beside me here is kind of 3 structures that the phospholipids form when they're in aqueous solution. You can see the first one, the large one, it's got that kind of cone shaped, and you can't see into it, but if you could see into the middle, it'd also be cone shaped. That's one way in which they can orientate themselves. That single layer with no metal, but the one that the membrane is aligned with, of course, is that bottom one, the lipid bilayer. So the phosphate heads on the outside, the tails on the inside, and based on the watery situation, the heads will be facing the water, the tails away. And that just comes back to that hydrophilic, hydrophobic, charged, non-charged, with the head being charged, polar, the tails being non-charged, non-polar, the head hydrophilic, the tails hydrophobic. Well, that's our video on the phospholipids. The next time we get together, we'll be talking about proteins. So we'll see you then.